What if the Earth stopped spinning but kept orbiting? This question comes from physicist Dr. James Rodriguez, who asks, if Earth suddenly stopped rotating on its axis but continued its orbit around the Sun, what would happen to our planet and all life on it? Let's imagine it's a Tuesday afternoon when the impossible occurs. At exactly 3 p.m. Greenwich Mean Time, Earth's rotation gradually slows down over the course of an hour and comes to a complete stop. The planet continues moving around the Sun at its usual orbital speed of 30 kilometers per second, but it no longer spins on its axis. The first thing you'd notice is that the day-night cycle would change dramatically. Instead of a 24-hour day, each day would now last exactly 1 year. For 6 months, half of the planet would bask in continuous sunlight while the other half remained in perpetual darkness. Then, as Earth moved to the opposite side of its orbit, the light and dark hemispheres would slowly switch. Within the first week, the temperature differences would become extreme. The sunlit side would begin heating up relentlessly, with no nighttime to cool down. Temperatures would climb past 50 degrees Celsius and keep rising. Meanwhile, the dark side would start cooling rapidly without any solar heating, dropping toward minus 100 degrees Celsius and beyond. But here's where the physics gets really interesting. When Earth stops spinning, the atmosphere doesn't stop immediately. The air would continue moving eastward at roughly 1,670 kilometers per hour at the equator due to momentum. This would create the most devastating windstorm in planetary history, with hurricane-force winds circling the globe continuously. These winds would be unlike anything ever recorded. Normal hurricanes are powered by temperature differences between warm ocean water and cooler air, but these winds would be driven by the sheer momentum of the entire atmosphere. Buildings would be flattened, trees uprooted, and anything not firmly anchored to bedrock would be swept away by winds that make the strongest hurricanes look like gentle breezes. The oceans would behave even more dramatically. Water, like air, has momentum, and when Earth stops spinning, all that oceanic water would keep moving eastward. Massive tsunamis would race around the globe, flooding coastal areas and redistributing water in ways that would completely reshape the continents. After a few months, something fascinating would begin to happen. The extreme temperature difference between the sun-facing and space-facing sides would create the largest thermal gradient in Earth's history. Hot air from the sunlit side would rise and flow toward the dark side, while cold air from the frozen hemisphere would flow back toward the hot side, creating a massive atmospheric circulation pattern. This global air circulation would be far more powerful than our current weather systems. Winds of several hundred kilometers per hour would continuously blow from the hot side to the cold side, creating a permanent global storm system unlike anything in Earth's current climate. But the most surprising effect would be on the boundary between light and dark. At the terminator line, the border between the sunlit and dark hemispheres, temperatures would stabilize at a moderate level. This narrow band, perhaps a few hundred kilometers wide, would become the only habitable zone on the planet. This twilight zone would experience perpetual sunset conditions, with the sun always hanging low on the horizon. Temperatures would be neither scorching hot nor freezing cold, making it the only place where liquid water could exist and life could potentially survive. Here's the twist that changes everything. After about a year of this new reality, scientists would discover that Earth's lack of rotation had an unexpected benefit. Without the Coriolis effect caused by rotation, the massive atmospheric circulation between hot and cold sides would be far more efficient than Earth's current weather patterns. The continuous flow of air from the sun-baked hemisphere to the frozen hemisphere would actually moderate the temperature extremes. The hot side wouldn't get as hot as predicted because hot air would constantly flow away, and the cold side wouldn't get as cold because it would constantly receive warm air from the sunny hemisphere. More surprisingly, this new atmospheric pattern would be incredibly stable. Unlike our current chaotic weather with storms, fronts, and unpredictable patterns, the tidally locked Earth would have perfectly predictable weather. The terminator zone would have constant gentle winds, stable temperatures, and regular precipitation as warm, moist air from the hot side cooled and condensed. The most unexpected consequence would be evolutionary. Life forms that survived in the terminator zone would adapt to these constant twilight conditions. Plants would evolve to photosynthesize efficiently in low-light conditions, while animals would develop enhanced night vision and different sleep patterns. But the strangest realization would come from studying Earth's new orbital mechanics. Scientists would discover that tidally locked planets might actually be more stable and hospitable than rotating planets. The constant atmospheric circulation would prevent the extreme ice ages and climate fluctuations that rotating planets experience. Earth's new configuration would represent a fundamentally different type of planet, one where climate is perfectly predictable, where the habitable zone is clearly defined, and where life could potentially develop in ways impossible on a spinning world. The day Earth stopped spinning would mark the beginning of our planet's most stable climate period in its entire geological history.